This is the lesson video for Chapter 7, Lesson 6, Similarity Transformations. All right, so we've been going over shapes and similar figures and how we proportionately enlarge or reduce similar figures. So we're talking about similarity transformations now. What's a transformation? It's whenever you have a shape, and there's a few different types of transformations here. There's 4. I'm going to go over. We're only focusing on the last one, okay? So a translation is a type of transformation that just slides a shape side to side, up and down, in a direction, right? There's a way to measure it, but when you see the word translation, you're just talking about sliding a shape. So the shape doesn't rotate, it doesn't flip, nothing else. It looks exactly the same. It just ends up in a different spot. That's a translation. A rotation is when you take a shape and you actually spin it, right, on an axis, on a center of rotation, and you can go clockwise or counterclockwise, and you measure how much you've rotated by degrees, right? So you can measure that as well. But a rotation is when you take a shape and you're just twisting it one way or the other. Okay, then the next one is a reflection. So that's when you actually flip a shape over an axis, right? And the axis can even be on top of it. It could actually end up lying on itself, but it's just when you take the shape itself and it becomes a mirror image of itself. You reflect it. It looks kind of like the opposite. Okay, so the last one we're going to focus on in this lesson is called a dilation, and that's an enlargement or a reduction. It's a type of translation where you have similar figures. So if we started off with a trapezoid and we shrunk it, right, by a certain amount, you have to be able to measure it, it would be smaller, or we could enlarge it and it would be bigger. But, and this is my hand drawing, so you know I can't draw great, but it should look exactly the same. It's been similar, all 4 sides here, all the sides have been enlarged or reduced by the same ratio. Okay, so that's what we're focusing on today is dilations, enlargements or reductions. So here it says identify, it's hard to read, it's far away, identify similarity transformations. A dilation, that's what we were just talking about, is a transformation that enlarges or reduces the original figure proportionally, right? So by the same ratio. The scale factor of a dilation, remember when we talked about similar triangles, right? And they increase or decrease by a scale factor. All the sides should have that same ratio. It's a scale factor. The scale factor of a dilation, in general, we call it K, just like in a slope, you know, whatever equation, we call it M. The slope intercept, y equals mx plus b. M represents the slope, b is the y-intercept. In this, the scale factor of a dilation, we always call it the letter K, is the ratio of the length of an image to the corresponding length of the pre-image, right? So the number on top is always the new shape after you dilated it from the original. The pre-image is the original, the image is the new, right? So it always says new over original. When you think about writing your scale factor, it's always the size of the new shape over the size of the original shape, whatever part of it we're talking about. All right. And then if that ratio is less than 1, then we know it was a reduction. It went down. If that ratio is bigger than 1, we know it was an enlargement, right? If that's confusing, just pay attention. We're going to do some examples. All right. So first, determine whether the dilation from A to B is an enlargement or a reduction, and then find the scale factor, right? So A is the pre-image. Seems weird to call it the pre-image because it seems like that's the image, and then once you do something to it, that's like the second image. That's not what they call it. B is after we've manipulated the pre-image, and now we get the image. So try and keep track of that. All right, so here, this is A, this is B, and I'll highlight A in yellow so you know this is the original. This is the one that goes on the bottom. This is the pre-image or the original. It goes on the bottom of our ratio. All right, so first off, just looking at this, it tells us it's a dilation, so it's not asking us if it's similar or not. We know it is. It's a dilation. So did this get larger or did this get smaller if it turned into this? obviously it got larger, right? So how do we measure that? If I just pick one side of this original image, let's say I pick this guy up here, and I'll put it in pink, and I measure it, that's 2 units, right? It's 2 squares here, that's 2 units, okay? So that's the original. What's the corresponding side on the new guy? So this side is now 4, right? 1, 2, 3, 4 squares. Okay, so the pre-image goes on the bottom is 2. The new goes on the top, new over original, is 4, right? I can simplify that to 2 over 1, and that's my scale factor, right? That's the factor of the dilation. I dilated it 2 units, 2 over 1. Is that number bigger than 1? If it's bigger than 1, then I know it was an enlargement. If it's less than 1, then I know it was a reduction. So is 2 over 1 greater than 1? Yes. So we know it's an enlargement. Yeah, you can look at the picture, and that's great, but you're not always going to have a graph picture. And you'll see that here down at the bottom. We're going to just start having these coordinates, and you're going to have to figure it out from that, right? Okay, let's do another one. Here, our pre-image is A. That's our original. And our new guy, here, and our new image, I guess, is B. So going from this guy to this little guy, it looks like we have a reduction, right? Well, how do I measure that mathematically? I'm going to look at this side, okay? This whole pink side. So if my original triangle image, remember it goes new over original, or you can think of it as the image over the pre-image. But if this original guy, which goes on the bottom, is 1, 2, 3, 4, 5, 6 units, that goes on the bottom. And then the new triangle, this little guy, is 1, 2, 3 units, just this portion is 3 units. So that's new over original. If I simplify that, I can do it down to 1/2. Is 1/2 greater than 1? Greater than 1? No, it's not. It's less than 1, so then this is a reduction. Less than k equals 1. So this is a reduction. And again, yes, I know that you can look at it and tell that it's a reduction. A was the original, B is the new. Clearly we shrank it down, but mathematically, how do you show that? You have to find one of the sides, the measure, compare it to the corresponding side of the new shape after you've dilated it, write it as a ratio, the new number over the original number. If that ratio is greater than 1, it's an enlargement, and if it's less than 1, it's a reduction. Okay, that's all we're saying. I know it sounds like a lot, but that's all we're saying. Okay, next, the distance between the vertices, blah, 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 blah. Okay, this is what it's telling us to do. We're going to apply, this still goes up here, but we're going to apply this down here now. I don't always like reading through it. I like to do my own thing. Okay. Oh, that's kind of we graph our own is in the next video. Sorry. We're eventually going to get to the point where it gives us coordinates, and we're the ones that are either graphing or just using distance formula or midpoint or whatever we need to do, right? So eventually you're not going to get a pretty little picture. You're just going to get something with coordinates in it, and you got to know what to do. That's what all this visual example stuff is right now. But we are going to stick with the pictures for now. The next video will get a little harder, part 2 of this lesson. Find the scale factor of the determine whether the dilation from A to B is an enlargement or a reduction, and then find the scale factor. So we're doing 2 things here. We're going to find the scale factor first, and then tell if the scale factor is less than 1 or greater than 1. That's going to tell us if it's an enlargement or a reduction. So you kind of have to go backwards from what they say. All right. So A, from A to B, it says A is our original. Okay, so here's A, this shape right here. And I'm just going to pick one side of it. The easiest side to measure is this flat bottom side. And so I'm going to compare it to the new dilated image, the same one of the corresponding side of the new dilated image. So from this guy, it's 1, 2, 3 units on the bottom. And then when we dilate it, this image B here, it's 1, 2, 3, 4, 5, 6 units on the bottom. So when I write the ratio of image over pre-image, the new image is 6 units, but it originally started as 3 units, right? So if I simplify 6 over 3, I get 2 over 1. That's my scale factor. And if my scale factor is greater than 1, then it's an enlargement. Is 2 greater than 1? Yes, it is. So this is an enlargement because 2 is greater than 1. Okay, let's do the next one. This guy right here. Our original image is this big A here. And then the dilated image is this little guy. So we're just going to pick a side. Now, I'm not picking these diagonals because, yeah, I can figure out the length of that diagonal. But to do that, I'm going to have to use the distance formula. If I just find the length of one of these horizontal sides, I can just count the boxes. I don't have to do the extra work. But eventually, we are going to get to the point where we do have to use the distance formula. All right, so here, and then the corresponding side is here. And this is 1, 2, 3, 4, 5, 6 units. And this one is 3 units. So remember, it's the image, the new image over the original. So the new image is 3, but the original was 6. A is the original, B is the new. So if I simplify 3 over 6, that goes to 1/2. That's my scale factor. Is 1/2 greater than 1? No. Is it less than 1? Yes, so it's a reduction. Because 1/2 is less than 1. Okay, why are we measuring it against 1? Well, it shows us, right? If it was 6 over 6, that means both of these would be a length of 6 and there wouldn't have been any change. If the top number is smaller, it means this big guy shrunk down. If the top number is bigger, it means this went up, right? So if the top's bigger, it means this whole fraction is greater than 1 and it's an enlargement. The top is smaller, like in this case, the fraction is still a fraction. It's less than 1, so it's a reduction. All right, 2 more. Number 3, our original here. Here's A. I'm going to measure the top of it, and I'm going to compare it to the top of B, right? So here, it goes new over original, image over pre-image. So my image is 1, 2, 3, 4 units. And my original is 1, 2, 3, 4, 5 units. Okay, so 4/5, that's my scale factor. I can't simplify it anymore. And is 4/5 greater than 1 or less than 1? Obviously less than 1, right? If you had a pizza and it was cut into 5 slices and you ate 4 of those, is there any pizza left? Yeah, because you didn't eat the whole pizza. You only ate 4 out of the 5. Well, still a lot of pizza, but you didn't eat the whole thing. You ate less than 1 pizza, right? So this is less than 1, and when the scale factor is less than 1, it shows that it was a reduction. The dilation was a reduction. 4/5 is less than 1. Okay, so if this number is less than 1, it's a reduction. If it's greater than 1, it's an enlargement. This number is our K value, our scale factor of a dilation. All right, so here's one that I was talking about. Let me just zoom in a little bit. There's no flat edge for me to count here. I can't count diagonal boxes, right? It doesn't go just straight diagonal half across a box. It's not what it does here. So how do I figure out, if I wanted to compare this original side to this new side, this new dilated side, how do I find the length, right? So I need to use the distance formula. Now I'm only doing it twice. I'm finding the length of one side, I'm finding the length of another side, and then I'm comparing them. So I don't have to do it like 6 or 8 times like I've done in the past, right? I'm going to do it down here on the bottom because I have room. The 2 coordinates for this big side, this is -1 up 4. And for this one is negative 3 up 0. So I need to know that to find the length of this, right? So d equals square root of x minus x squared, negative 3 minus negative 1, plus y minus y squared, 0 minus 4. Okay, minus a negative becomes a plus. Negative 3 plus 1 is negative 2. Negative 2 squared is 4. 0 minus 4 is negative 4. Negative 4 squared is 16. And that becomes square root of 20. Okay, and then for this guy here, I need to find the length of that. So this top point is over 3 up 4. And this one is 2, 2. Okay, so same thing. I'm going to find the distance formula. X minus x squared. So, 3 minus 2 squared plus y minus y, 4 minus 2. And you can't see that great. And then I simplify. 3 minus 2 is 1. 1 squared is 1. 4 minus 2 is 2. 2 squared is 4. So that becomes square root of 5. Okay, so now I got to figure out, is this greater than or less than 1, right? So how do I write the ratio? Well, remember, it's new over original. So this length over this length. This length right here is square root of 5. This length right here is square root of 20. So I'm going to write square root of 5 over square root of 20. And then if you remember from algebra, your rules of radicals, right? Everything goes under radical. 5 over 20, which simplifies to 1/4. And of course, we're finding the square root of 1/4. So I can separate it back out. Square root of 1 over square root of 4. The square root of 1 is 1. The square root of 4 is 2. So my scale factor of new over original ends up being 1 over 2. And that's less than 1, so it's a reduction. And we can see that it's a reduction. Okay, hopefully that made sense. I know it was all over the place here. All I did was find the length of these two sides with the distance formula. When you write your scale factor ratio, it's new over original, so square root of 5 over square root of 20. And then I had to simplify that mathematically. Okay, once you have radical signs on the top and bottom, this fraction becomes a fraction under one big radical sign. 5 over 20 is the same as 1/4, all under one big radical sign. And just like I changed the two top and bottom to one big here, I can go backwards. So I change from one big guy to the top and bottom again. And then square root of 1 is 1, square root of 4 is 2. Okay, let me know if you have questions.